Hello everyone and welcome to Applications Manager's free training series. Thank you for taking your time out and being here today. In part 1, we'll be looking at how you can monitor and track your critical workloads on AWS platform. In part 2, we'll be looking at how you can gain insight into the performance of your Azure services and Kubernetes containers, and a special mention about Azure Kubernetes service, which was released recently. And in part 3, we'll be looking at how you can detect your service outages, application lags, server downtime, and other bottlenecks inside and outside your cloud environment. And finally, we'll be looking at how you can track the performance of your Microsoft Teams application. So before we go in depth about today's topics, let's take a look at the cloud in general. The cloud movement started garnering attention in the early 2010s and has grown exponentially ever since. As you may know, we have three main types of clouds. One is the public cloud, which most of us use. And the second one is the private cloud, which is mainly being used for security purposes. And the third one, which is the hybrid cloud, which has a mix of both public and private cloud in the infrastructure. In 2021, it was predicted that 90% of the enterprises would move to the cloud by Gartner. But these predictions usually downplay the actual value to avoid overestimating, and we can see that 94% have already moved to the cloud. When you look at the market value of the cloud, it's estimated at $445.3 billion in 2022 and is expected to grow annually at the rate of 16.9% to $832.1 billion in 2025. The market is growing rapidly. And if the pandemic and the subsequent remote work culture has taught us anything, it's how dependable the cloud actually is and how much we've grown to depend on it. If this trend continues, I expect the market value to cross $1 trillion by the end of 2025. Now, why do people adopt the cloud model? One of the main reasons why organizations are lining up to adopt a cloud strategy is how easy and quick it is to migrate to it. In a traditional data storage method, the amount of data stored is directly proportional to the physical storage space it occupies. But that's not the case with cloud storage. You can store any amount of data without having to worry about how much you have to scale, not only physically, but virtually as well. This technology is also incredibly flexible. It allows you to scale new resources quickly, control workloads, and ensure a seamless end-user experience. It also provides an easier and a more systematic approach to disaster recovery scenarios and also to handle multiple workloads. But even though the cloud offers a myriad of benefits, it comes with a few challenges such as mapping dependencies, limited visibility into the underlying operations, and lack of control. Cloud applications can be dependent on multiple clouds and on-premises technologies. They may be dependent on hundreds of elements, and discovering these elements is quite tricky. Some of these elements in the cloud architecture are complex, and the visibility into them is often minimum. And the lower the visibility, the lesser control you have over the output. Sometimes, unscheduled downtime and increase in application latency can occur. Now consider this scenario. You want to perform an action which consumes a lot of data. This would make it both time intensive and complex. Now you want to perform another action which has to wait until the first action is fully executed, since it uses the same resources. This results in a deadlock situation, thus causing the application to slow down. In a worst case scenario, it may even result in server crashes, thus causing downtime. Companies could lose millions along with their reputation if they encounter this situation. Since the visibility into cloud structures is low, it becomes harder to troubleshoot and optimize the performance unless a third party is involved. Now, this third party is the monitoring tool that helps you overcome these challenges, and that's exactly what Applications Manager does. Applications Manager is an infrastructure and a server monitoring tool, which also provides application performance monitoring on the side. It offers monitoring for over 150 technologies, including databases, cloud servers, normal service and other infrastructure elements. It also automatically discovers the applications and maps their dependencies. Take a look at this flow diagram to understand how Applications Manager works. So in the cloud infrastructure, you have various elements such as the compute elements, containers, applications, and servers. So you also have the native monitors such as CloudWatch for AWS, Azure Monitor for Azure Cloud, Google Cloud Operations Suite for Google Cloud, and OCI monitoring for Oracle Cloud. These monitors also provide an insight into the cloud infrastructure, but the only metrics they provide is only for the services that they offer. What Applications Manager does is it has a metric aggregator which sends an API request to all these native monitors. It then aggregates and collects these metrics and processes into useful information, which can be used to manage the faults and to analyze the historical trends and predict the future usage trends as well. This information is available in the Applications Manager console, which you can also view in your mobile apps as well. So Applications Manager monitors all the popular technologies such as AWS, Microsoft Cloud, Microsoft Azure Cloud, Google Cloud, Oracle Cloud, and Microsoft 365. And also containers such as Kubernetes, Docker, and OpenShift. But today, we'll be focusing on the two most popular cloud technologies, which are AWS and Azure. So here I will be discussing how you can add and monitor the critical metrics in AWS and Azure using Applications Manager. So first off, we'll be looking at how you can monitor your critical workloads on AWS. So Applications Manager collects the metrics for the Amazon Cloud Services through the Amazon CloudWatch. It makes use of the appropriate APIs for different services to collect the data, which is then aggregated and compiled using AWS SDK. The performance of a system can be defined in terms of the system's ability to perform a given task successfully. This performance, if the tasks are executed successfully, is measured by the time taken to perform the task, the rate at which the tasks are performed, and the resources consumed while performing the task. In general, the efficiency of a given system can be expressed in terms of performance. And the metrics that you need to monitor are the metrics related to the time taken to perform the task, the rate at which the tasks are performed, and the resources consumed. I'll reveal the metrics that you need to monitor to keep your services running and to ensure steady performance in a short while. Before that, we'll take a look at how you can add the Applications Manager's AWS monitor in the console. So let me go to the console. So this is how the console looks. And in order to add a monitor, you need to go to New Monitor, add New Monitor. And under Add New Monitor, you have the Cloud Apps. And under Cloud Apps, click on AWS. Here, you need to specify a display name. For example, test. And you can choose which services that you want to monitor. If you do not wish to monitor any of the services that are listed here, you can simply just remove them. And you have to specify the access key and also the secret access key. If you have a specific account type, you need to specify it as well. By default, AWS Global is chosen. And based on the account type that you choose, you can change the regions. As such, you can see that you can change it based on AWS China and GovCloud. You can also choose whether or not you want to discover and manage the child monitors. In advanced settings, you can plan whether you want to take an action on the deleted resources, such as continue alerting or to stop alerting. If you want to manage the resource, you can do so. And also you can delete the resource as well. You can also use a regex to filter the EC2 instances. And if you want to stop discovering, you can simply just stop discovering and you can mention the services that you want to stop discovering. Specify the polling interval and you can add the monitor. When you add the monitor, the status will be displayed here. If you have any problem with adding the monitor, the status would be failed. Now let me go to the monitors and show you what are the metrics that you can monitor in AWS. But before that, let me show you how you can collect the data as well. In Applications Manager, you can also configure how you want to collect the data. Simply go to Performance Polling under Settings and select your desired option. So here under Data Collection, you would choose Amazon. And under Amazon, you'll be able to configure the performance polling settings, such as if you want to collect the S3 storage statistics via CloudWatch API, if you want to enable auto-scaling alerts for EC2 instances. And if you want to do that, you can select it, check it, and based on it, a health severity will be given as critical or warning when the EC2 instances are being scaled. So if you don't want to get the alerts, simply just uncheck it. And if you want to optimize the data collection, go to Data Collection, Optimize Data Collection tab. And under the Optimize Data Collection tab, click on any of the cloud apps that you want. For example, I'm choosing Azure Kubernetes Service. So here, the performance or the health of the Kubernetes service will be dependent on these metrics. So if any of these metrics are being overused, or if they have a problem and they become a bottleneck, the node health will be shown as unhealthy. And for Amazon, you can choose to configure by the monitor type or types if you want to collect the data or to collect the data every poll, or you can also collect the data at the customized poll interval, such as you can give it in minutes or in hours. Click Save to save. So let's take a look at the metrics that you can monitor with Applications Manager. You have a separate tab here, which is listed here under Cloud. And under Cloud, so you have all the types of monitors added. So I added test right now, so you'll be able to see. Since I added it just now, the availability is minimal based on the polling interval. So you have the compute resources. It gives you the general rundown of all the services that you can monitor, except for S3 buckets, SNS, and SQS. All the others give a general summary of the services under it. You can view the extensive data listed under those services by clicking on it. When you click on compute, you have three types of compute elements. One is the EC2 instance, the other one is the Lambda, and the last one is the Elastic Beanstalk environment. By clicking on any one of this service, or the entry, you will be able to view the underlying data. Now in EC2 instance, the overview tab provides a general overview. Like I said, since I just added the monitor, the graph is quite empty, and but you have the metrics here as well. So the OS level metrics gives you a general snapshot of the EC2 instance. And if you want to collect the OS level metrics, the CloudWatch must be deployed inside the EC2 instance. Let me show you how it looks like in our demo site, where we've already added the monitor. So here it will be available under Cloud Apps and under Amazon. By clicking on Amazon, so in compute, so yeah, this is how it would look like if you've been polling the data for quite a while. So the CPU utilization is important here. And if you find that your EC2 instance is down for a while, and also the CPU utilization is being used at a maximum, then the CPU utilization must be the bottleneck. So like I said, you need to monitor the metrics related to the time, the rate, and the resource. And the resource metrics are CPU utilization, network traffic, and disk I/O over here. You can also view the OS level metrics, where you can monitor the memory related metrics and the disk utilization metrics. And under attached volumes, you will be able to monitor the volume versus idle time, which is a time related metric. volume versus read-write latency, volume versus read-write bandwidth, and volume versus read-write throughput. Moving on to Lambda, when you click on the entry, you will be able to view the underlying details. So here the important metrics are the metrics related to the invocations, the invocation rate, and the execution. So the executions describe the rate at which the invocations are executed and the rate of success achieved. So here you will be able to view the success rate, error rate, and the invocations per minute. And under invocations, you can actually view the failed invocations and the throttled invocations as well. So the duration of the invocations execution is given here. You can also monitor the iterator age and the async delivery failures. The configuration tabs gives you a general configuration detail about the EBS. And moving on to Elastic Beanstalk, it has the overview tab, which provides the general overview about the instance. And under instance, you will be able to view the instances which are okay, the number of instances which have been degraded, severe, pending, warning, etc. It also has the inventory details. And here you need to monitor the resource utilization, such as CPU, disk, and network traffic. So when you monitor all these, and if you come across any bottlenecks, such as the incoming traffic being more than the outgoing traffic, or the outgoing traffic being more than the incoming traffic, it means that the bottleneck is the network traffic, and you need to work on it to fix it in order to optimize the performance. Under requests, you will be able to monitor the response summary, which gives you the if error is being shown, it will give you the number of 2xx responses, 3xx responses, 4 and 5xx responses in a graphical and a tabular format. So in latency, you will be able to view the application latency and the top 5 instance latencies. So the application latency, P99, is the latency or the time taken to complete 99% of the tasks, and the 90% of the tasks. Here it will be the 75% of the tasks. And under instances, you'll be able to view the CPU usage and the disk usage of the instances as well. And you have the configuration details also listed here. Under events, you have the event details. So these events are generally displayed when there is an event or when there's an error in the request. So moving on, we have the containers tab, where you will be able to view the ECS clusters and the EKS clusters. Under ECS clusters, you'll see that it is tightly integrated with EC2 and Fargate instances. So the resources monitored under cluster performance are the resource are given over here. So here you'll be able to view the resource usage, and if any of the resource if there's a shortage in the resource, it will definitely affect or impact the cluster performance. The important metrics that you need to monitor here are the running versus desired status of the tasks, and it will be given here. So the last status and the desired status, and also the connectivity, if it's being connected or not. And also you need to monitor the pending versus running versus desired tasks over here. It will give you a general overview of whether the resources or the services are allocated properly, and if you need to rightly allocate them. In container instances, you'll be able to view the resource utilization of the container instances over here, and also the running and the pending tasks as well in the container instances. And in EKS clusters, which are Kubernetes clusters being deployed in Amazon Web Services, you'll be able to monitor the metrics related to nodes, pods, services, the persistent volumes, and the service map. So under Overview tab, you have a general rundown of all the nodes and the namespace details. And under Node, you will be able to view the node usage details, the top 5 nodes by memory and CPU. You also have the node pod details, wherein you will be able to see how many pods are deployed in the node. And also you have the node details as well. So if the pod usage is more in the node, the color red would be more here. And if you notice that it's being overused, you need to deploy more pods in the nodes. Under pods, you'll be able to view the pod details, the status of the pods, the start time, and the created time. You can also view the top 10 pods by memory and CPU. You can view the number of containers in each pods, the CPU limit, the CPU request, memory limit, etc., and also the container details. Here you need to monitor the container restart details as well, as it will give you the general information about how the performance of the container in the pod is actually. Under services, you will be able to view the service details and the deployment details, and under persistent volumes, you will be able to view the persistent volume details and the persistent volume claim details. So the service map provides a general graphical map view containing the namespace and service details. Moving on to databases, you have 3 types of databases here. One is the RDS instance, where you can also monitor the Aurora instances. And the other one is the DynamoDB tables. In RDS, it enables users, as you know, RDS enables users to provision and operate relational database management systems in the cloud and can be deployed on widely used database engines like MySQL, Postgres, Oracle, MS SQL, and Maria database. So here the important metrics are the metrics related to resources, which is given in the Overview tab, where you can monitor the CPU utilization, storage, available memory, swap usage, and database connections. Under Disk I/O, you will be able to monitor the I/O throughput, the latency, and operations, where you can see the throughput, read-write throughput, the read-write latency, read ops, write ops, and the pending iOS requests. Under network, you'll be able to view the incoming and outgoing traffic, and the configuration tab gives you a general rundown about the configuration. Moving on to DynamoDB. Under DynamoDB, you can monitor the read capacity, the write capacity unit, mainly related to read-write operations. So under read operation, you will be able to monitor the read latency, get latency, the query latency, and the scan latency. And in write operations, you'll be able to view the write latency, put latency, batch write latency, delete and update latency. In the table errors, you will be able to view which errors were shown. So if it was user errors, the user errors are here, system errors, conditional check failed requests, and the time taken to live a deleted item. In the global secondary index tab, you will be able to view the GSI read capacity units, write capacity units, throttled events, and online index consumed write capacity and online index throttle events. It also provides you details about the configuration and the creation. And under streams, you'll be able to view the latency of the streams, the return bytes, and the return records count. The configuration tab provides you a general detail about the configuration of the DynamoDB. So moving on to Elastic load balancers, you have 2 types of Elastic load balancers: application load balancers and network load balancers. So under application load balancers, the main statistics that you need to monitor are the connection stats, the latency, healthy and unhealthy host, which are given in the target groups. So Here, the unhealthy and the healthy hosts are given here, and this is one of the most important metrics that you need to monitor. So that if there's an unhealthy host, you can optimize it and make it healthy to maximize the performance of the ALB. You also have the target tab where you get the target details. And under errors, you'll be able to view how many errors were thrown along with the load balancers error or the connection errors. So moving on, we have S3 buckets. So here, the general statistics about the S3 buckets are shown here. And the main metrics that you need to monitor are the metrics related to the requests. So you can monitor the total requests, total get requests, put requests, and the latency of the requests. And you can also monitor the bucket size and if the number of objects in the buckets are rightly allocated or not. Under SNS service, you'll be able to monitor the messages and also the notifications. Here you can view the total messages published, delivered, and failed. And also you can monitor the charges for messages. You can also monitor the message throughput and the delivery and the failure rate. Here you can see the region-wise metrics where you will be able to view the messages published, notifications delivered, and failed for each of the regions. Under SQS, you'll be able to view the details by clicking on any one of the entries. So you will be able to see the performance rate of the queues, wherein you will see the arrival rate and the completion rate, the breakdown of P4 messages and the processed messages, along with the age of the oldest message and the size of sent messages. Moving on to billing, it is one of the most interesting feature available in Applications Manager. It helps you monitor the expenditure incurred by using the AWS services. So it gives you the breakdown of the services and the taxes incurred per month, or where you can see the month-to-date services cost and the month-to-date taxes. You can also see the expenditure and the forecast of the current month. And you can also see the month-to-date top services by spend and the month-to-date spend by service. So these are the services monitored in Applications Manager, like I mentioned, and I've shown in the console. So moving on to second part of today's session, let us take a look at how you can track and monitor the important KPIs in Azure Cloud Services. So in APM supports various Azure Cloud elements such as Azure VMs, storage accounts, SQL databases, service buses, and Kubernetes service. So let me show you how it looks in the console and how you can add the monitor. So under New Monitor, Add New Monitor, click on Cloud Apps and Microsoft Azure. You have to give the display name, the subscription ID, and you have to specify which services that you want to monitor. By default, all services are mentioned over here. And if you wish to not monitor any one of the service or more of the services, you can simply remove it. Choose the account type, whether it's Azure Global or Azure Cloud, and the discovery mode. Based on the discovery mode, you need to specify the details in a different manner as well. If you choose the AD application and service principal discovery mode, you need to specify the client ID, the tenant ID, and the application key. If you choose the Azure organizational account using PowerShell, you need to specify the email and the password. And if you choose the OAuth, you need to choose the OAuth provider. If you don't have an OAuth provider already configured, you can add a new OAuth provider over here. You need to give the provider name, the grant type, the redirect URL, the client ID, client secret, and everything else you need to mention over here if you have an OAuth specified. So I'm going to choose discovery mode as Azure organizational account. So let me give a test email ID. And you can also give the timeout and specify the polling interval as well. So I have added the monitor, and since I've just added the monitor, the metrics that I've collected would not be shown in detail. So let me show it in the demo site. So under Cloud Apps, you'll be able to view it over here. Click on Microsoft Azure. It'll give you a list view, and when you click on the entry, you'll be able to view the overview tab, where you have the overview of all the resources being provisioned, like Azure virtual machines, storage accounts, premium storage accounts, SQL databases, service bus, and the Kubernetes service cluster. So under virtual machines, when you click on the entry, you'll be able to view the underlying details. So here, the metrics that you need to monitor are the metrics related to resource usage mainly, which is CPU, memory, disk, and disk. So under CPU, you will be able to view the IO wait time, idle time, and the processor time. If the time increases for each of this, it means that it is a bottleneck. And under memory, if the memory is being overused, such as this one, so if the used memory is closer to the available memory, then it means that the memory is being overused and you need to allocate more memory resources for this particular instance. And under disk, you can monitor the read throughput, the write throughput, the disk IO ops, latency, etc., and also the disk spacing as well. The health of this virtual machine is dependent on all these metrics, and if any of these metrics are said to be overused, then the health would be shown as unhealthy. So under network, you can also view the network traffic metrics like incoming and outgoing traffic. So moving on to storage accounts, you have the standard storage account and the premium storage account. Based on your provision, you can view the underlying details. So in storage accounts, you can view the metrics related to blobs, tables, files, and queues. Under blobs, you can monitor the capacity, the throughput, the latency of the blobs, and also the requests failed by the throttling errors, the timeout errors, and other client errors as well. You also have other server errors and authorization errors, and also the successful requests being made in the blobs. Similarly, for tables, you have the same, where you can monitor the requests failed by throttling errors, timeout errors, and other types of errors. For files, you can view the same for the requests failed by the errors. And under queues, the same is provided. So you can actually view the client errors and the timeout errors for the queues as well. Moving on to Azure SQL databases, the important metrics are the metrics related to queries by default, because in any SQL database, the metrics that you need to monitor are the ones related to queries. So here you will be able to view the top queries by the resources such as CPU, IO, queries and waits, and slow running queries. So the metrics that you need to monitor are the top queries by CPU. Since if it consumes a lot of resource, it could be a bottleneck, so you need to monitor these. And the top queries which consume the most time to get executed will cause a slowness. So you need to monitor the slow running queries as well. If you monitor the frequently executed queries, you can see to it that it is being executed without any bottleneck. And the most blocked queries will give you a general idea about whether it's getting blocked or not. And you can also view the top CLR queries and waits as well, which will provide you with the waiting tasks, the wait time, the average wait time, and the signal time. So let's move on to the service buses. Under service bus, you can monitor the metrics related to queues and topics. And the general overview is given in the overview tab, where you can see the namespace details, the request details, the message details, and the connection statistics. Under queues, you will be able to view the top queues based on the incoming requests and the messages. You can also view the queue metrics, where you can monitor the incoming requests, successful requests, throttled requests, etc. Under topics, you will be able to view the same. So you can view the active topics based on messages and the incoming requests, and also the number of incoming requests, successful requests, throttled requests, etc. So before I go to the Kubernetes service that you can monitor in Microsoft Azure, let me continue with the Kubernetes container orchestration platform. Let me tell you about how you can gain into the performance of your Kubernetes container orchestration platform. So as you know, Kubernetes, it is also known as K8, is an open source system for managing containerized applications across multiple hosts, and it's mainly used for automating software deployment, scaling, and management. It is becoming the de facto compute control plane for not only cloud native, but also for on-premises apps as well. It offers a built-in implementation for both internal, which is the east-west traffic, and the external, which is the north-south traffic load balancing. A typical Kubernetes architecture consists of multiple clusters, and a cluster consists of a set of worker machines called nodes, which run the containerized apps. Now, each cluster has at least one node, and the nodes host pods, which contain one or more containers which share the same resources. So the persistent volume is a storage element that is provisioned by an admin or is dynamically provisioned using storage classes. And a service is an abstract way to expose an application running on a set of pods. And the deployment is responsible for keeping a set of pods running. And like I said, a service is responsible for enabling the network access to a set of pods. So let me show you how you can add the Kubernetes monitor. Go to new monitor and add new monitor. And under monitor, you will be able to view the Kubernetes container under virtualization. To add the Kubernetes monitor, you need to specify the display name, the cluster or the host IP address. You can choose whether or not to use a credential list from which you can select a credential. So it's already given here, or you can specify a new credential as well. You can choose to use a public key authentication. And if you check on it, you have to give the private key as well. So you need to specify the username, private key, and the passphrase over here. The prompt is by default is given as a dollar symbol. You can also use a greater than symbol or a hash symbol as well. You can specify the SSH port. And if you want to monitor specific namespaces, you can filter it based on conditions like include or exclude the namespace names. Specify the timeout and the polling interval. So when you give these credentials, you should be able to test the credential. And when you test the credential, if the credentials are if the credentials work, then you should be able to add the monitor. If it doesn't work, you won't be able to add the monitor. So since I have tested the credential, so these are dummy data that I have given. So it should be it should end in failure. So I won't be able to add a monitor. But let me go to the monitors tab and show you the KPIs that you can monitor. So in Kubernetes, you'll be able to monitor the metrics related to nodes, pods, services, and persistent volumes. So In the Overview tab, you will be able to monitor the namespace details, the pods, the top 5 nodes by used pod count, the cluster usage details, and the other details as well. Under nodes, you can see the top 5 nodes by memory details. So if a particular node is using a lot of memory, it could cause a bottleneck. And if a particular node is using a lot of CPU, it could cause a bottleneck as well. By monitoring the top 5 nodes in both memory and CPU, you will be able to decide which nodes need to be provisioned with more memory or CPU. You can also view it in a tabular format here, where you can monitor the allocatable memory, the memory limit, the memory request, and the CPU processor count, along with the CPU limit and request. Under node pod details, you will be able to view how many nodes are provisioned, or how many pods are provisioned in a node, and whether or not to provision more pods in the node. And under node details, you'll be able to view the node general details about the node, such as OS image, OS architecture, type, etc. Under pods, you will be able to view the pod details, where you can see the status of the pod, the start time and the created time, along with the top 10 pods by memory details and CPU details. It also gives you the details about the number of containers in each pod and how much CPU is being used by the pod, along with the memory usage as well. You can also view the container details, and here you need to monitor the container restart count and the container status. Under services, you'll be able to monitor the service details and the deployment details. And in deployment, you can see the deployment replica count and the deployment available replica count, based on which the deployment availability is shown. So since the deployment available replica count is 0 here, the availability of the deployment is down. Under persistent volumes, you can view the persistent volume details and the persistent volume claim details, where you can see the access mode, storage class, and the capacity of the volume, and also the PVC requests received. So moving on, these are the KPIs that you can monitor in Kubernetes, the metrics that are related to the Kubernetes, and the metrics which are important to be monitored. So moving on to Azure Kubernetes Service, it's the newest service released on Azure Cloud. It helps you deploy, run, and scale Kubernetes clusters in Azure Cloud. It also helps you automate the provisioning, the maintenance, and scaling of the Kubernetes clusters. And the monitoring of the Azure Kubernetes service is similar to the typical Kubernetes monitoring. That's why I showed you the Kubernetes, how you can monitor the Kubernetes containers first. And it's also very easy to monitor, with Applications Manager's hybrid platform monitor. So we've already added the monitor here. So let me go and show you how you can monitor the Azure Kubernetes service. So under Cloud Apps, you'll be able to view the Kubernetes service. And under the Kubernetes service, the Overview tab provides a general information where you can view the cluster information, cluster details, the namespace details, etc. Here, you need to monitor the pods ready percentage for the namespace details. If the pods ready percentage is lesser than 100, that means some of the pods in the namespace are not available or not ready. So the pods ready metric is mainly dependent on the container's availability status and the readiness rule specified in the pod readiness tab. So you can also view the cluster CPU and memory details, the node details, the top 5 used node pods, the node phase, where you can view the total failed pods, pending pods, the running pods, unknown pods, and successful pods. The total unknown pods are the pod status for which the Status is unknown. You can also view the component details. And under node pool, you'll be able to view the node pool details, such as the VM size, the status of the node pool, and the utilization details as well. Under node, you can see the top 5 nodes by memory details and CPU details, which is basically the same as the ones we saw in the Kubernetes container. And you also have the node usage details, where you can monitor the CPU, disk, and memory of the node pod details, where you can view the pod usage details in the node and also the node details. Under pods, you'll be able to view the pods running. And since there are a lot of pods which are being deployed in the namespace, the top 10 pods are shown in this tab. If you want to view all the pods, you can click on show all, and all the pods will be shown here along with the details. So if you should monitor the pod status over here, if it is running or if it's degrading, and the pod age as well. So it also gives you the top pods by memory details, CPU details, and along with the number of pod containers in each pod, and the usage of the resources by the pod. You also have the container details, where you need to monitor the container's restarts and the status of the container. And moving on to services, it gives you the service and the deployment details. And persistent volumes gives you the persistent volume and persistent volume claim details. The service map gives you a graphical representation of all the nodes and the clusters in the Kubernetes service in Azure Cloud. So moving on to third part of today's series, we have how we'll be looking at how you can detect service outages, application lags, server downtime, and other bottlenecks inside and outside your cloud environment. So how can you prevent service outages? In Applications Manager, you can prevent the service outages by creating and associating threshold profiles to key performance indicators. You can also trigger automated actions to be performed under breaches. So with the help of anomaly profiles, you can also easily detect the performance degradation and application issues. So the alerts are generated when thresholds are breached. These can be escalated via email and SMS. So when a service is down, Applications Manager automatically identifies the source of the issue with root cause analyzer, and corrective actions such as cloud action can be triggered automatically when you associate it with the threshold profile. Let me show you how you can do that. So if you want to create a threshold profile, you can go to threshold profile, and under threshold profile, click on new threshold profile. You already have a few threshold profiles which are already being specified. So you can also view them as well. So let me show you how you can create a new threshold profile. So if it's a numeric value that for which you want to create a threshold profile, just click on the numeric value. If it's a string value, click on string values. And if it's a float value, click on float values. For numeric values, name the threshold. Let me name it CPU utilization. And you can mention the severity as well. For critical severity, if the monitoring value is less than 5%, for warning, if it's equal to 5%, for clear, if it's greater than 5%. You can also use polls, and you can give a description, and you can also apply it based on the business hour and create the threshold profile. So since it already exists, we'll be able to associate it with any monitor now. So you can have an adaptive profile as well, wherein you don't have to specify the values, and it will be decided based on the baseline values. So you can give it based on the baseline values of the previous week, or you can also use a custom expression as well. So if you want to specify it as a percentage, you can specify it as a percentage. And you have the critical severity, warning severity, and clear severity, for which you can specify the threshold limit as well. Click to create threshold profile to create the threshold profile. Now you have the threshold profile over here. So all the threshold profiles will be listed here. And if you want to associate it with any of the monitors, you will be able to associate it by going to configure alarms and select the monitor type. So by configuring the health, you can associate any threshold profile or action. So here it's given configure actions at attribute level. So you can choose the available actions and the associate actions over here. So in order to create the anomaly profiles, go to new anomaly profile, give the details such as the anomaly profile name, whether you want to detect anomaly based on the baseline values or the custom expression. And if you give the baseline values, if you can base it on a fixed baseline or a moving baseline based on the previous week's data. If it's a fixed baseline, you can choose the week of the month's report data. So you can also specify it as percentage of the baseline, and you can create the anomaly profile. So, and then if you want to configure actions, you have a lot of actions that you can configure. Since we are talking about the cloud, the main action that you can configure is the cloud action. So give it a display name, such as CPU utilization. So here you can select the monitor type. You have two types, basically, Amazon and Azure. So if it's Azure, you can choose whether to start, stop, or restart the VMs. If it's Amazon, you can choose to start, stop, or restart the instances. And after the action is being executed, you can specify a notification action as well, specify the email, and create the action. So you can also analyze the application lags. So it can be identified and analyzed extensively with Applications Manager's APM Insight agent. In week 2 of this series, we discussed about the application performance management. And if you want more information, I recommend you to check out our webinar in the YouTube. So how can you prevent the server downtime? So Applications Manager monitors various types of services, database services, app, VMs, and other infrastructure elements, as I previously said. You can map the dependencies between all the cloud and non-cloud elements to gain a deeper visibility. So when you monitor these in synergy with the cloud services, you'll be able to achieve an all-round high performance across your IT infrastructure. So if you do that, you can preempt any issues that may result in unresponsive service. And by using our analytics or advanced analytics, you'll be able to anticipate the resource usage, where you'll be able to predict the resource usage and growth with our forecast and capacity planning reports, and make educated decisions. Now, moving on to last part of today's series, how can you track the performance of your Microsoft Teams application? So Microsoft Teams application is a proprietary business communication platform developed by Microsoft as a part of the Microsoft 365 family of products. So what can you monitor with Applications Manager? With Applications Manager, you can monitor the service health, the usage, team stats and details, activity, channel stats and details, and issues. So I'll show you how you can monitor it. To add the monitor, go to New Monitor and click New Monitor. Under Cloud Apps, click on Microsoft 365. So unlike all the other cloud apps where I showed you, you need to specify the services here. So you have 3 services listed. Click on Microsoft Teams, give a display name, the tenant name, the user email ID, and password. If you want to monitor the service health, you have to check on the service health monitoring and give the tenant ID, client ID, and the client secret. And by clicking on add monitors, you'll be able to add the monitor to be monitored. So to check the KPIs, go to monitors, and under Microsoft 365, you'll be able to view the Microsoft Teams. And under Teams, you'll be able to view the overview tabs, which gives you the service health details, issue details, endpoint connectivity. And in Teams and channels, you'll be able to view the team details and monitor the channel count along with the member count in each of the teams. And the channel details, you'll be able to view the member count in each of the channels. So under usage, you'll be able to view the number of users based on the device type per day in the last 30 days. And also you can view the user count based on activity types such as private messages, team chat messages, calls, meetings, etc. You can also view the activity count based on the activity time. So here it will show you how many chat messages have been sent, the private chat messages, calls, etc. This is different from the user count, wherein it will show you how many users have made a team chat message, and the activity shows you how many team chat messages have been made. So moving on. You can also, like I said, you can monitor the service degradation issues here. So that is it for today. A quick recap of today's session. In the beginning, we saw how you can proactively monitor your AWS platform, how many services that you can monitor, and the KPIs that you need to monitor in each of the service. In part 2, we saw the KPIs that you need to monitor in Azure Kubernetes and a new service, Azure Kubernetes service. And in part 3, we saw how you can detect, resolve anomalies and issues inside and outside your cloud environment by using Applications Manager's fault management system. And in part 4, we saw how you can track your MS Teams accounts and usage based on the activity and the number of users and the number of devices that they use. Thank you for tuning into today's session and staying till the end. I hope you all have a good day. Until next time, this is Angie.